Okay, so first question that we need to ask ourselves is what is an acid? So what do you think an acid is?
Solution. I got solute. There's no solution.
So the solution. Acids have to be a solution. Good. But here's the thing. What do you know about acid right now? Do you want to hold acid in your hand?
No.
Do you want to pour acid in your head?
No.
You want to drink acid?
No.
Why not? What is your perception?
Because it burns.
It burns. It cuts through things, right? It can go through anything. That's most people's idea, and that's to a certain extent it's true. But let's talk about what an acid is exactly that allows it to be so corrosive. Now, acid. One definition of acid, the one I like, is that acid is anything that produces H+. What does H stand for?
Hydrogen.
Hydrogen. Okay, so what is hydrogen? Let's take a look at that. Hydrogen has how many protons?
2 or 1.
One proton, right? And if it's neutral, if I just have hydrogen, how many electrons will it have?
1.
One. That make sense?
Yeah.
So this is my neutral hydrogen. Now, an acid produces what? Hydrogen ions. So if I put a plus here, how do I make it a plus? What do I need to remove?
The ion.
The electron.
Yeah.
So if I remove the electron, what am I left with?
The proton.
A proton. So what is H+?
Proton.
Just a proton. H+ is a fancy way of writing proton. Now let's think of proton. Proton has what? One positive charge. Now, what do you think about that? Like, how strong would that be, you think?
Nothing.
I want you to think about this, okay? There's a positive charge. It really wants an electron. Who can stop it from getting an electron? No one. He'll take an electron from anybody. Now, if you think about our bodies, what holds us together? Ionic bonds or what? Ionic bonds or covalent bonds? Covalent bonds. Covalent bonds are together, why? Because of the electrons.
Because it's like, yeah, because negative.
They're sharing electrons, remember? So when a proton by itself comes through, snatches away the electrons. And that's why you don't want to be touching this stuff. You don't want to be pouring acid, at least a strong acid, on your hands. So when you think acid, you should think protons. It's just a high level of proton. And protons are highly reactive when it's alone. Why? Because you're used to having an electron with them. If they don't have an electron with them, they just go crazy. So the definition of an acid is what? Produces protons. This is one definition. Okay? Now, what did these protons do to be so effective? They remove electrons. So another definition of acid is something that removes electrons as well. You get that? Now, so what would the definition of base?
Something moves electron, like adds
Removes protons.
and adds electrons.
Don't worry about electrons right now. You're kind of right. But right now, I just want you to focus on the simplest definition, and we can make it more complicated later. But it removes protons. Does that make sense? So an acid does what? Produces protons. Bases removes protons. So acid base, you should be thinking protons, 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 protons. That's it. We're playing with protons. Before we talked about ionic bond, covalent bond, we were talking about electron, 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 electron. Now what are we talking about? Protons. So do you understand this?
Yeah.
So good. So that's a good definition. Now, do you think in chemistry, now we're doing that, let's look at a laboratory situation, okay? Do you think that you're going to be able to have a beaker full of protons? No, I just told you they're highly reactive.
Yeah.
So you need to store them in some way. Now, protons love what? Positive, or what do you think they'll love more? Positive or negatives?
Yeah, positive.
Positive. So this is, you know what I'm drawing here? What is this?
That's periodic table.
Periodic table. What's this column right here? Noble gases. Okay, what's next to noble gases? Halogens, right? Do you agree?
Yeah.
Now, what's the first one? Fluorine, chlorine, bromine, and iodine. What charge is this?
Negative.
-1. Everything here has a -1 charge. The proton is what? A +1. So don't you think they make a really good fit?
Yeah.
Yes. So acids, we generally want to bind them with a nice negative. So for example, HF, HCl, HBr, and HI. So, look at the halogens, right? HF, HCl, HBr, HI. Now, what happens when you put this in water? What's going to happen? This is what kind of bond? Ionic bond or covalent bond? Ionic. Ionic, because it's a non-metal with a metal, or a positive with a negative. So this is an ionic bond. Do ionic bonds dissolve in water? Yes.
They do?
Yes, they dissolve in water. Ionic bonds dissolve in water. So when I put HF in water, what's going to happen? What is it going to produce? It's going to dissolve, right? Into what?
Into
H plus and?
F minus. Okay.
Did this produce protons?
Because since the negative and positive can react.
Yes, because the negative and positive is going to break up, it dissolves. So does HF produce protons when put in water? Yes. So is this an acid?
Yeah.
Yeah, by definition it's an acid.
Okay.
How about HCl?
It's an acid also.
It's an acid. How about HBr?
It's an acid.
And how about HI? So these are all acids. Now, this acid has a very special name. Okay? These are called binary acids. Binary acids. Why? Because there's only two of them. When we look at the polyatomic acids, you'll see there's more than just two. Now, normally you would call this hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. But because these are acids, we call it, we have a little bit of a different name. We call it hydrofluoric acid. And what are we going to call this, you think?
Hydrochloric acid.
Hydrochloric acid. And what are we going to call this?
Hydrobromic acid.
Hydrobromic acid. And the last one? Hydroiodic acid. I know it's a tough one to say. Okay? So what are binary acids? Tell me. Hydrofluoric acid, hydrochloric acid, hydrobromic acid, and hydroiodic acid. If you ever forget, go to your periodic table. It's the top four in the seventh column next to the normal gases.
Okay.
Now, we're going to get into this in a little bit. But these are also known as strong acids. Okay? So remember these are strong acids. We'll talk about the difference between a strong acid and a weak acid later. But just remember this is a strong acid. Now, so these are our binary acids. So now I kind of told you there's also another one, right? Polyatomic acids. Right? What are polyatomic ions? Can you name some polyatomic ions for me? Remember carbonate?
Okay.
Remember that?
Yeah. Like NO4.
Yes, anything that has more than one, right? Remember those? Okay, carbonate, and this is carbon. Okay, so that's carbonate. What else we have? We have this is nitrites, and this is what?
Nitric.
Nitrates.
Nitrate.
Does that make sense? So this is -1 and this is -2. Do you remember this? You have to go back and review your polyatomic. It's going to become important again.
Right.
Okay, now, how do I make this an acid? Add a hydrogen to it. See, it's a -1, right?
Oh, yeah, okay.
So you just add a hydrogen to it, right? So it's going to be, so if I add a hydrogen to this, it's going to be HNO2. Okay, how do I make this an acid? H2NO3.
Right.
Does that make sense? Now, this ends with what?
Nitrate.
ITE. ITE. So if it ends with ite, we call it nitrous acid. So if it ends with ITE, when it becomes an acid, we call it OUS. Does that make sense? Now, what is this nitrate, right? What does it end with?
ATE.
ATE. So what do we call that? Instead of if it ends with ATE, then we end it with ic.
So nitric
acid. Huh?
Nitric acid.
Nitric acid. Does that make sense? So how about sulfate? So SO42-. This is sulfate.
So it's
What
gonna
would
be
this be as an acid? First, tell me the molecular formula.
H2NO3.
H2SO4, right?
SO4.
And what would you call this?
Um,
Sulfuric acid, right?
Sulfuric, okay.
Sulfuric. IC, because why?
Yeah.
Because it ended with ATE.
Okay.
So that's the breakdown for acids.